just grab a seat. I did learn that it looks like we have run out of our handouts, which in one sense is wonderful in terms of the level of turnout that we had. We made about 200. So what we will do is we will post this handout on our website so that you have it, and I will also send it along to principals so that they have it so you can grab it if you were not able to get a paper copy this evening. Good evening. My name is Mary Beth Banyos, and I am the Assistant Superintendent of Schools here in Shrewsbury. And I would like to welcome you to our K-5 Math Parent Night. On behalf of all the educators in our district, I also want to thank you for partnering with us, as is evidenced with your arrival here this evening in your child's education. As most of you are aware, Shrewsbury has begun a K-8 implementation of a revised math curriculum this year. Our goal in doing so has been both to ensure that we're aligned with the Massachusetts state math frameworks, but also to ensure that we increase our effectiveness in supporting our students to be solvers of complex problems and to be critical thinkers. We spent the 2013-14 school year piloting Math and Focus materials as the core resources to support our curriculum revision. Math and Focus is the US version of Singapore mathematics. After piloting both the materials and the curriculum last year, there was broad consensus from our pilot teachers that our new program both maintained the skills associated with a more traditional math program, while at the same time increase the rigor and expectations around solving complex math problems. This year, all of your students in grades K through 5 are engaging with the Math and Focus materials and the new Massachusetts math standards. Some of the problem-solving approaches in Math and Focus may be new to many of our parents. To this end, we felt that it would be particularly helpful to hold an information night so that parents can understand the intent of these approaches. This evening, I am pleased to introduce to you Dr. Richard Biss. Dr. Biss has given presentations at local, national, and international conferences on his work with the mathematics books from Singapore, and he is a consulting author with the Math and Focus textbook series. Along with his consulting work, Dr. Biss is a professor of mathematics at Worcester State University and has taught numerous pre-service and in-service courses that focus on improving the mathematical understanding of teachers. He is also currently running a 3-credit graduate course here in Shrewsbury for approximately 25 of our elementary educators. Please join me in welcoming Dr. Biss to this evening's presentation.
So when I agreed to come here, I was imagining 30 people. So this is really nice to see. So how many of those of you who are in elementary school would say that you love math? This is pretty. A lot of people, I saw people who were like 35 years old answer that question. I said in elementary school. And for those of you who are out of elementary school, maybe parents, if I did a quick survey on maybe a scale of 1 to 5, thinking back about your experiences as a student, where a 5 is you love math, and 1 was you couldn't wait to be done with it. And if it's a 1, please, you're going to show an appropriate number of fingers. 5 is you love math. And if it's 1, please use this finger. I'm seeing a range. I'm seeing more 5s than usual, which is really nice for me, because one of the occupational hazards of being a math professor is people come to you at parties, and it's like true confessions about how much they hated math. And what am I supposed to say? Well, sometimes I say, I really couldn't read very well. And sometimes the person gets the message, sometimes they don't. I don't know if anybody played with this problem that's up here. Yep. Anybody solve it? And what grade would you think this problem is? Fourth grade, 3rd grade, high school? Okay. 7. Well, I'll tell you where I got it from. It was on the 2005 MCAS in Massachusetts. It was the question that the largest number of students got wrong, and it was a grade 10 question. Yes. It gets worse. Okay, it gets worse. It was a multiple choice question. And there was really only one reasonable answer. I'm going to come back to this question later. So, this is me. My day job is teaching math to college students. And when I started doing that, I really never imagined I was going to work with elementary school teachers. So I'm going to tell you a little bit of how I got there, and in a sense, how I got to be here today. This is kind of what I'm going to talk about. A little bit about myself, and I promise you, it's like about 2 minutes worth. Some talk about why there became an interest in math books in Singapore in the US. What are the key characteristics of those books? And I'll show you some examples from some of the pages. And after that, there'll be some time for some questions. Although with a couple hundred people, obviously you can't all ask questions. I have to go home at some point. So I am trained as a mathematician. I have a PhD in math from Clark. Most of my career has been at what I would call teaching colleges and universities, where our primary job is to teach, not to do research. And in that capacity, what I've seen is large numbers of students who are unprepared for college level work. I would say the majority of math courses taught at colleges and universities in this country consist of topics that are also taught in high school. They have different names, but it's high school. They have to be taught faster than college. Roughly, very few of our students come thinking about STEM careers, STEM being science, technology, engineering, and math, which are really important areas in the state. And in my place, I'd say, fewer than 10% of them are prepared for calculus. Certainly fewer than 10% of them take calculus, which is really the gateway course to a lot of careers. All of this led to an interest in my part in college preparation issues. And so what I see as challenges from where I sit in my own job is, why do lots of students come to me with a whole bunch of math weaknesses that limit their career options? And then even those who are strong in math often don't like it. So you have people who do really well in math, and they still have the attitude, the last thing I want to do is see another math class. So I'm going to give you my first Singapore math experience. There must be a good joke here, but I think I'm going to behave myself. You can tell me the good jokes about this later. I was asked to teach a 10-day course in 2000 using the original books that came over from Singapore. Actually, the same books that we used there. I had never heard of the books. Mostly I agreed because I hate writing grants, and someone else often did the paperwork. If somebody could do the nasty paperwork and I got to do the fun teaching part, I was in. So fortunately, when the books came, they were quite impressive. Now, the original books that I used were really skinny, they were like 100-page paperbacks with barely any words. And that's kind of the format of the books that are used over there. Currently, there are sort of two versions of what gets referred to as Singapore math in the US. And I should point out, in Singapore, they don't call it Singapore math. They call it math. Singapore math is actually a trademark name by the first company that imported the books here. And they published what's called the Primary Math Series, and they now currently publish 3 versions of it. The 3 versions are not that different from each other. Math and Focus, actually the Primary Math Series is no longer used in Singapore, mostly because they changed the national syllabus, and the Primary Math Series doesn't match the national syllabus. The best-selling book in Singapore now is called My Pals Are Here, and Math and Focus is essentially a US adaptation of it. So those books were taken and adapted essentially for US market, because a lot of what you see in books in a lot of Asian countries is so different from what teachers are used to here that it's a big leap for a lot of teachers. So the attempt was to create a version of the books that looks like what teachers and students are more used to seeing. And there's advantages and disadvantages. I could talk for an hour about that, but I won't. I do want to talk briefly about why anybody started thinking about Singapore in the first place. And there's essentially three reasons. A series of international studies that go by the acronym TIMSS, which stands for Trends in International Math and Science Study. The lead organization on this is Boston College. If you do a web search, you can get tons of information on the methodology. You can argue about the methodology, but the main point I'm trying to make is these studies showed strong performance in those countries. It called people's attention to what was going on. The National Math Panel did its work in the mid part of the first decade of the century, and they came out really well. I'll show you a couple quotes from there. And then more recently, the Common Core State Standards, and I'll show you some quotes from there too. Singapore is a pretty small country. I grew up in New York City. Singapore is smaller than New York City. You can drive from end to end in 45 minutes, and the taxis are much cheaper, as is the subway. They have the third highest per capita income in the world, but if you go back to the 60s, they were pretty poor. And they don't have any natural resources. It's kind of a city-state island nation, and they decided that in order to survive and prosper, they had to invest a lot in education. And a lot of what they do, they didn't invent on their own. They looked around the world for best practices. I was fortunate enough to spend a chunk of a sabbatical there at the beginning of last year. And I have tons of pictures. I can spend an hour showing you pictures, but I won't. I just want to show you two that I find kind of cool. Those are fairly large buildings, maybe 30 stories tall. The thing that looks like a boat on top looks like a boat. And there are trees growing out of it. This is a place called Gardens by the Bay. And they're like 100-foot tall trees, 200-foot tall trees made out of wire, and there are vines growing up them. And I don't know if you can see, there's a walkway that goes between two of them, and those are people on the walkway. So I took the picture mostly so people could see scale. This is a little graphic showing TIMSS results from 5 of the TIMSS studies. I actually found this in Wikipedia. And what you'll notice is that in many of the years, this is grade 8. Many of the years, Singapore was the top country. It wasn't the top country, it was second and third. And the top countries tended to be Singapore, South Korea, Taiwan, Japan. So you might say, well, why their books and not the books from the other countries? Well, the language and instruction in Singapore is English. So somebody can go over there and buy the books and bring them over here without changing. And the original books I worked with were the same books I used there. Theater was spelled R-E at the end. Honor was spelled H-O-N-O-U-R. Instead of using the word exponent, they used the word index. It was a great multicultural experience for the children using it because they could see how the English language varied across the world. This is the more recent TIMSS study. This is 4th grade. You see they're back on top. Just like with MCAS, where there are different categories, you know, advanced, proficient, we have needs improvement. There were different categories for TIMSS. And notice the second column has the percent in the top category. And so it's not just the overall average score that's fairly high, but the percent scoring in the top category is pretty high. Those are the people who often become your scientists and your engineers. By the way, the TIMSS scores are scaled so that the international average is 500. And that's shown at the bottom. Same information for grade 8. Here you see South Korea happens to be first. But again, notice the large number in the advanced category. The U.S. broke the top 10 for grade 8. We did not break the top 10 for grade 4. This last go-around, they did something fairly interesting, was they asked the children a question kind of along the lines that I just asked you, except I think it was paper and pencil. It wasn't showing a number of fingers. They asked the kids how they felt about math. And here are the results. So you'll notice here I'm showing the percentage in the advanced column. But then if you move to the last 2 columns, you're seeing like math, dislike math, and there was sort of a neutral category in between. So notice that there's a much more positive view of mathematics in Singapore than there is in a lot of the other top scoring countries. After I had gone to Singapore, I went to South Korea for a few days to do some PD work at an independent school there. And one of the big issues they have in South Korea is the kids feel so much pressure in terms of achievement that you have the highest suicide rate in the world in children. And I actually got this slide from a fellow from Singapore that I went to South Korea with. He used this slide in the parents' presentation. Because part of what he wanted was, we want the children to learn math, we also want them to love math. We don't want them to do well in math because they're fearful of what's going to happen if they don't. The National Math Panel consisted of mathematicians, math educators, who in this country are typically at each other's throats. There's something called the Math Wars, some of you may have heard of. If you haven't and you want to while away an entire weekend, do a web search for Math Wars, and you'll find people on each side calling people on the other side idiots. So they put together a group, I think it was about 30 people. It was 1/3 mathematicians, 1/3 math educators, and 1/3 cognitive psychologists. I think they were the referees. So here's a couple of their quotes. I'll let you read. Everybody can see this and read it, right? So I don't have to read this to you. And a comment about the textbooks in the US as opposed to the textbooks in Singapore. And so this was 2007. I saw this in 2000. In fact, some of the first groups of teachers I worked with kept saying things like, our kids can't do this, these problems are too hard. And in one group of teachers, after a couple of days of that, one of the other teachers turned around and said, let's stop thinking about what our kids can't do, let's start thinking about what they can do. I actually think the teachers who were concerned were nervous that they found the mathematics just a little harder than they were used to seeing. It was putting more of a load on them in terms of their own background. This is from the Common Core Standards. This is the second paragraph of the introduction. So they're essentially saying, we looked around the world at the high-performing countries, and we said, what are they doing right that we're doing wrong? And then this is from further down the first page of the introduction. Again, talking about how weak a lot of our textbooks are. If you go online and you look at the Common Core now, and I encourage everybody to do that, because when I read stuff in the newspapers about the Common Core, I would say that 90% of the time the person writing the article has not looked at the Common Core. Because it's amazing how many things are stated that are untrue. There was an article in the Boston Globe magazine this past Sunday. I don't know if anybody saw it. No? Don't read it. Or if you do read it, go read the Common Core and see if they're talking about the same document. Either way works. Go to the original source, is what I'd say. Anyway, the part in red, as the Common Core was coming out, because I had been working with these books for so long, I was pleased with what I saw in various drafts. And so I was giving talks like this. And this was a slide I used. And this entire quote was in the last draft before the final version. The part in red was removed from the final version. I don't know why. If I had to guess, it could be that some US textbook publishers did not want that there for competition purposes. But I don't know for sure. This is what Singapore calls their curriculum framework. It's a different use of the phrase than we have in the US, because a curriculum framework in the US usually means a lot of detail about what should be taught. It has, lists for each grade level. Curriculum framework is more along the lines of what's in the Common Core. So notice that problem solving is the focus, that the purpose of mathematics education is problem solving, and they list a whole bunch of things around them. One of my favorites these days is perseverance. There's been a lot of research lately about the issue of, I think it's the shorthand is grit, that a lot of US students tend to give up on a math problem after 15 seconds. because they felt they've worked a long time on it. And even my college students are like that, unfortunately. So I tell them about students in other countries where people don't give up for 30 minutes or for a day or two. It's a whole different approach, and I think that's something we have to work on here. So if you look at the curriculum, this curriculum framework from Singapore, I actually took some things and highlighted them in red. And the reason I highlighted them in red is the Common Core has a list of mathematical practices, which I'm about to show you. I will show you the same ones highlighted in red. Notice the first one, make sense of problems and persevere. So how important perseverance is. That mathematics is about reasoning. Getting the correct answer is important, but being able to do the reasoning is important. Being able to construct arguments is important. Again, I can let you read the rest. But you'll find that a lot of teachers who are getting professional development about the Common Core are focusing on these areas. So some of the key characteristics of Singapore math. The biggest one is depth over breadth. Typically, they have taught fewer topics in a given year. They teach you from mastery. The typical U.S. curriculum says, we're going to teach you 40 or 50 topics in a year. Don't worry if you don't get them, because we'll teach them again next year. A number of years ago, I wanted to look at what was then the best-selling textbook series in this country at the elementary level. One of my colleagues had copies, so I borrowed, I think it was the 4th grade book and the 5th grade book. And in the way that life sometimes happens, I put the books in my office, and I got busy for a month. And I looked at them a month later. I picked up the books. It didn't say which was 4th grade and which was 5th grade. I thought, this should be easy. I'll look at the table of contents. It looked like the same table of contents. Finally, on the back of the book, I found it in code. One book had 5 dots on the back. One book had 4 dots on the back. Other than that, there wasn't a lot of difference in the math content. In my mind, that's not a good message to send to kids. About, I think it's maybe 8 or 9 years ago, well, this slide will have the date on it. 9 years ago, the Federal Department of Education commissioned a report comparing the U.S. math education system to the Singaporean one. You can find this online if you're interested. It's about 200 pages long. I mean, it's not just the books, it's a whole bunch of other issues that are involved. And this graphic essentially, actually I retyped this to make it easier to read, looks at the primary series of Singapore math, compares it to what was then considered a reform series, everyday math, and a traditional series, Scott Forsman. And what you'll notice is that at each grade level shown, grade 1, grade 3, grade 6, in Singapore they would teach way fewer topics per grade, but spend more time on it. Because their goal was mastery and understanding, not just one. We want children to know 7 times 5. We want them to know that 7 times 5 means 7 groups of 5. Because if all you know is that 7 times 5 is 35, and you see no application for it, you really don't know that much. You need to know both. The appeal to a lot of mathematicians, so a lot of university mathematicians first got interested in these books, is because how clearly the math was developed. They use an approach called concrete pictorial abstract, which essentially means you introduce things at a concrete conceptual level before you formalize things. And this can happen at almost every level of mathematics. So as an example, there's pictorial. Here's abstract. Here's concrete, right? Concrete is physical materials. Pictures is some kind of pictorial representation. There's nothing about this symbol that means this many. That's an abstraction you have to learn. In the same way that when you're 5 years old, you have to learn when you put the 2 next to the 3, it doesn't mean 2 plus 3. It has a different symbolic meaning. When you put the 2 over the 3, it means something else. But if you make the 3 a power of the 2, it means something else. And you can go on and on, all these different things that 2 and 3 mean, depending upon where those two symbols are juxtaposed. All of that is symbolism that has to be learned. A lot of emphasis on problem solving. They use a technique called model drawing, which some of you may have seen your children come home with already. I don't know if they've all gotten to it at this point in the semester. I'll show you some examples shortly. Is the feedback okay? Every now and then I hear it. Okay. A lot of the problems are multi-step, meaning you can't just say, we finished the chapter on multiplication. We're doing some word problems. So my job is to find the numbers in the problems and multiply them together. Which is, I know I used to do that when I was in elementary school. And I'm not sure how much that actually helps you. There's a big emphasis on mental math. You know, can you multiply 13 times 98 in your head? Well, you might say, it's 98 13s. You know what 100 13s are? That's 2 extra 13s. So 100 13s is 1,300. Remove the 2 extra 13s. You go 1270, help me.
94.
Okay, good. I just want to make sure you're following me here. You know, most of my classes are 30 or less, so I'm really more used to stuff where there's interaction. I know I can't do that with 200 people, but it feels weird to me. So you'll have to excuse me. And in general, what I've seen is a much higher level of expectation in terms of achievement in these books. So there's a stress on conceptual understanding, which is really a big word in mathematics today. So the goal is not just how do we get the answer, but why do we do that? So you want mastery and you want understanding, which sometimes means you need to have practice. But it's not just drill, you have to have the drill that's based on understanding. So the two essentially will bring you. So a bunch of examples. This is probably my favorite part because I feel like I'm talking about stuff without doing the math, and my natural tendency is just do math. So this is from the 3rd grade book. And in the 2nd grade book, what they do is they work on the multiplication facts up to the 5s. So it'll be 5 times 2, 5 times 3, times 4, all the way up to 5 times 9. And let's assume you get to the point, because you're spending enough time on it, the children have mastered it. They learned that 5 times 6 means 5 groups of 6. And that you can represent 5 groups of 6 by 5 rows of 6 dots. With me so far? So let's say someone now says, let's do 7 times 6. Well, 7 times 6, we've already learned that 5 times 6 is 5 rows of 6 dots. It's just 2 more rows. You know what 2 rows of 6 dots are. We did that when we did the 2's table. So you construct 7 times 6 as 5 times 6 plus 2 times 6. Now, eventually, you want the answer to 7 times 6 to be immediately 42. But along the path there, you've got a means of constructing that and understanding where that 46 is coming from, rather than simply being an isolated fact. And there's an amazing amount of stuff that children have taught the first 3 or 4 years of mathematics. And if you believe that place value is a simple concept, you need to spend 2 hours with me. I'll give you a whole bunch of place value activities. We'll do them in a different number base. Once you do them in a different number base, you appreciate the complexity of what we teach our students between kindergarten and grade 5. If I had 2 more hours, we would do that. In fact, that would just be like all we did. That was actually the first thing I did with some of your teachers. We counted, we added, subtracted, multiplied, and divided in base 5. And I have to say, they were pretty good. I was impressed. So another page. So what's going on here? We're doing the 9's table. Well, the 9's table is a little bit like the 10's table, except you've got an extra one. So here we've got 4 times 9, which is the same as 9 times 4. And with that array model, that rectangular model, you can see why they're the same because you turn one sideways. So 9 groups of 4, well, 10 groups of 4 is way easier. So figure out what 10 groups of 4 is, and then subtract 4. You with me? You ready for me to test you? No? Did anybody say yes? Okay, quick. What's 10 times 80? No. I can't say that. What's 9 times 89? What's 10 times 89?
90,
And that's 1 extra 89, right?
801.
So get rid of that 1 extra 89, and we got 801. It's not that hard, but you have to teach it in a systematic way. And in the second and third grade book, there are tons and tons of pages like this one here for helping them master multiplication facts. In first grade, there's a big emphasis on the relationship between addition and subtraction. So you'll see these things called number bonds. If any of your children used everyday math, they were called fact families. It's the same concept. And essentially that picture is representing 4 different number facts. 3 plus 7, 7 plus 3, 10 minus 7, 10 minus 3. Seeing the interrelationship makes it easier to learn. If you see it as one coherent whole rather than as 4 separate facts. You'll see them using these things called tens frames, which is another way of representing that information. So, suppose you have a child, I went too fast there, sorry. Suppose you have a child who has mastered what's called addition within 10. So as long, 3 plus 6, 3 plus 7, nothing gets past 10. And then the next level is 7 plus 8, for instance. Now the child, okay, phones in my class are not allowed. Someone's staying after school. So the child who's mastered addition within 10 might look at the 7 and think that picture. They might also think, what do I need to get to 10? Well, what's missing there? And because they've worked with this enough, and when they're working with this initially, you might think, boy, they're going really slow. But the reason they're going slow is when they get to this level, they have to go faster. So they say, well, I need 3 more. Where can I get 3 more? Well, I can take 8 and break it down into 3 and 5, and then I can combine the 7 and 3. This is essentially a picture version of the associative property. So, I mean, that's where the mathematics heads to, but you wouldn't call it that in first grade. Here's a version you might see. This actually comes out of Math in Focus first grade. So they're adding 8 and 6. I think those are apple cherries, right? My screen is so small I can't. It just kind of reminds me of what's next. But you can see what's happening, I hope, that 2 of the 6 cherries are moving over to join the 8 cherries. So you're thinking about 8 plus 6 as being the same as 10 plus 4. This one I'm going to skip. This is a class I visited I'm going to show you some pictures from some classes I visited in Singapore when I was there. This is a first grade class, and I went in January, which is actually the beginning of their school year. So the teacher started out with a story that involved 2 and 1 make 3. She wasn't using any mathematical language. Eventually the children were drawing these number bonds. You can see whole, part. So this is more pictorial, this is a little bit more abstract. Over here, they were making 10 in different ways. So the children were given 10 of these unifix cubes that snapped together, and they were asked to break them into 2 pieces in different ways. So you can see whole, part, whole, part. There's the 10, there's the 6, there's the 4. Now they're getting a little bit more abstract. They're actually writing equations. So it started out with a story problem, and it ended up with 4 plus 2 is 6. But some of the children were writing part, whole to remind them of where this came from. That we're combining a part that has 4 and a part that has 2, and we're combining them together. And again, you might think this is really slow until you get to, whoops, Forgot the slide was here. The slide, by the way, the slides are really for me, not for you. The slides are to remind me not to skip something. So this is from the first grade book. You'll see a lot of use with base 10 blocks, which were not invented in Singapore. I believe they were invented in this country. They're essentially place value blocks. And if you look at a problem like this, you might say, well, I'm adding 50 and 34. No, up here, I'm sorry. I'm adding, oh, I'm sorry, I'm on the wrong page. Okay. Here we're just representing numbers. I apologize. We're representing them by thinking of 54 as 5 10s and 4 1s. So even though you might say, well, I know 54 is 5 10s and 4 1s, the child is just 5 years old, it might not. And you might get even more concrete. Here, 63 is 6 bundles of 10 and 3 individual sticks. Here's another representation of the same thing, except we're going to higher numbers, and we're thinking about 1s, 10s, and 100s. How many parents have seen this kind of stuff before? And for how many is this entirely new? A few, okay. What's going on here is really an attempt to make clear the language of place value. And if you look at the history of mathematics, going back 5,000 years, place value took a long time to be discovered. People used to count all kinds of different ways. It wasn't like somebody woke up one morning and knew about place value. There's a long history that got us to where we are. And part of this is going through some of this with children so they actually internalize what these numbers mean. So here's what I thought was the slide 2 slides ago. So notice that we're adding 145, 352. Now, we as adults know, and our goal is to have your children know, that you can simply do that problem by adding the columns. Yet, we don't want to simply do the problem by adding the columns, because we want to make sure the children understand what adding the columns represents. We want them to understand that the 1 in 145 represents more than the 4, even though 1 is a smaller number than the 4. So you're going to see them spend a lot of time with base 10 blocks on problems like this, because then when they get to problems, and I hope this is the next slide, like this one here, where they look at the 7 and the 9, the most common wrong answer a teacher will see for this problem would be 4, 6, 1, 6. You see where I'm getting that from? Because the child who's been asked and told, just add the columns, will add the 7 and the 9, and they'll write 16. And then they'll add the 2 columns. Instead, we're saying, let's think about what that 7 and that 6 mean. I mean, that 7 and that 9 mean. It means 7 1s and 9 1s. Now that we have 16 1s, we can take 10 of those 1s and trade it in for 10. So you're going to see a lot of language of exchanging. Exchanging 1s for 10s, 10s for 100s. Play money is a great model for this, essentially. And this will go on and on, from first grade to second grade to third grade. You'll see versions of it with decimals, too. So this is the class I thought I was going to show you from Singapore. This was a second grade class. And again, this is second grade, maybe the second week of school. Okay? A big jump from what I was showing you before. So notice the problem at the top. You have to exchange twice, right? You can't subtract, you can't take 3 1s away from 1 1. You've got to trade in one of the 10s for 10 1s. Right? You can't take 7 1s, 7 10s away from 2 10s, or now you're down to 1 10. You've got to trade in the hundreds, and so on. So notice the child is doing this with magnetic base 10 blocks. The teacher, the way this actually classroom session went, the teacher did a problem, went through it with the base 10 blocks, and then had the children work on problems, and then had the children share answers. Each of these things I'm showing you, I can elaborate on for half an hour. pretend like we'd be here from 10 or 11. And I need to go to sleep. It's been a long week for me. So I'm trying to show you some samples from different grade levels. In the same way that addition and subtraction are related, you have division and multiplication related. So most people I find, if I say, what is division? You know, make up an example of division. It'll be something along the lines of, I have 12 cookies to share equally among 2 children. Right? Kind of the equal shares model. But there's another model of division. I have 12 cookies. I'm going to put 2 cookies in each bag. How many bags will I use? That's a grouping model. In both cases, you have this relationship between division and multiplication. So the key first is for them to understand that division is the opposite of multiplication, and then to realize the other 2 are actually applications. So you'll see that in the books. So here, you've got 12 pencil sharpeners put in 2 equal groups. Notice the little check in the thought bubble essentially is making that connection between the division and the multiplication. And then a page or 2 later, you've got this one here, where a child is given 35 cubes and asked to put it in groups of 5. So you may see your children doing activities like this before they're even told that it's called division. They might be just told, here are 35 cubes. Here's a bunch of cups. Put 5 cubes in a cup. How many cups do you use? Because you can do that problem without using any of the formal mathematical language. You develop the concept first, and then you move to the formal language. That way the formal language has meaning. So my favorite part. If I only have 10 minutes to talk about math from Singapore, I show people model drawing because it's what I call the sexy part of Singapore math. It's nice to be able to call my field sexy because so many people think of it that way. Thank you for laughing. So I'm going to show you a 3rd grade example, a 4th grade example, a 5th grade example, and then a 6th grade example. So here's the 3rd grade example. Okay? There are my 3 examples. So here it is again. 2 numbers add to 36. The smaller one is 1/3 of the larger one. Here's a picture of the situation. Do you see how the smaller one is 1/3 of the larger one? Those pieces get called units. Later, when they transition to algebra, the things that are units become x. But it's a more concrete version of algebra, essentially. And I know that the total is 36. I'm going to put that there. So now I have 4 units that total 36. I'm going to write that down. There we go. If I know what 4 units is, I can figure out what 1 unit is. I can divide by 4. I get 9. I can figure out what 3 units is. 3 units are, right? Okay. Just because I teach math doesn't mean I don't think reading and writing are really important, because they are. And some of my college math students, when I make them write, it drives them nuts. Because